Okay, welcome to the first video for 6B Mechanics. We're going to start just in this video here by talking about the idea of resolving speed. So we've resolved forces before, which means when we break up diagonals, essentially, into vertical and horizontal, that's what it looked like most of the time. We're going to do the same now with sort of the initial velocity, the initial speed called u. So we're going to have questions in just a moment where, if that's the ground, the particle is going to travel like this, okay? So instead of just going horizontally and then falling, it's going to go up at some sort of angle, okay? This is often called theta or alpha or something like that. But you'll remember from the previous part of the video, we just said that we need to break it up. We need to break up questions so that it's in terms of horizontal and vertical. So this diagonal is sort of a problem, okay? It's sort of a problem. Now the secret to doing it is thinking about our right angle triangles and thinking about sine and cos. So I'm just going to read you all that one there. I'm going to do it with theta. So I want you to pretend that the diagonal is called u. So that's the speed, right? It's the speed because it's made up of that vertical and the horizontal velocity together. So that's the scalar, that's called speed. Well, if I put a right angle triangle on there, you'll remember that sine, for example, sine theta, yeah, if I write sine theta on a right angle triangle is the opposite. So the opposite is, I'm going to call this, I'll call it uy, all right? So the opposite would be uy, and uy is the vertical, okay? It's the vertical, come on now. It's the vertical velocity. So it's the vertical over what? Over the hypotenuse, which in this example is u. So if you rearrange that, you get that u sine theta, yeah, that's the vertical velocity. So if, for example, over here I got given 15 and I wanted to deal with this side over here, what I would do instead is I would say 15 sine theta. Okay, I wonder if you can guess what the other one would be. I'm sure you can. So if this one here is the horizontal, if we make a cos equation, we can say that cos theta equals ux, yeah, where ux is going to be the horizontal. Now, you might think I'm flip-flopping a bit with my language here, but horizontal velocity, or you could say horizontal speed here, that's not wrong. Let's just kind of try and do it the proper way and call it the horizontal velocity. Okay, so horizontal only over u, and that means that u cos theta is what you want to use when it comes to the distance, speed, time part. So this will be the right value for your that part, yeah? This will be the right value for your distance, speed, time part. So rather than go through all of the examples now, we're just going to practice this a couple of times. So let's do a quick example of that. So let's call this 30. We often get 30, 45, 60 as our angles. And let's call the launch, so the initial speed, the launch speed, something like that. Let's say that that is 20 meters per second. So if you were filling out your distance, speed, time and your SUVAT columns, what are we going to put for our S and our U? You can make up positive, okay? What would we put for our S and our U figures? Pause the video and just have a quick go. So for this, it would be, this would be 20 sine 30. And you should have found that that was 10 exactly. Whereas for this one over here, this would have been 20 cos 30. Okay, and cos 30 is root 3 over 2. So off the top of my head, what's that? 10 root 3, I think. Okay, so that's how you would do it. And yes, the sine one will always then be the vertical, and the cos will always be the horizontal. Okay, so first key idea, before we go any further, we should be happy with breaking up our vertical and our horizontal.